All right, so now we're continuing on with the Unit 9.5 notes that we had started earlier. This is the second page of them. So now we're actually going to take that idea of direct, inverse, joint, and combined variation, and we're going to have to look at equations to determine which one of them it is. So when I look at these, my first step would be to look at what the general setup is. So first, I would make sure that one variable is isolated. Or in other words, alone. So if I'm looking at this number 1 right here, right, my y is already by itself, which is a good start. If it wasn't by itself, I would need to solve for that variable before identifying whether or not it is direct, inverse, joint, combined, or none. Okay? So that one's already by itself. Once you've got the variable by itself, then I look at the general setup. If all the variables are on the top, or the same line, then I know that it's one of two things. It will either be direct variation, or it will be joint variation. And remember, when we were talking about joint variation, there had to be more than 2 items multiplied together. Whereas when we talk about joint variation, it's really just the constant times the variable. So there would be only one of those variables combined with the constant. On the other hand, the other thing that I would look for was whether or not it was a fraction with a variable in the denominator. Because if there's a fraction with the variable in the denominator, there are 2 options that we have to think about. There's either inverse. So there's an inverse would be if the variable is only in the denominator. Or it could be combined. Right? And combined happens when there's multiplication and division. So in this case, there would be a variable in the numerator and denominator. Okay, so the most important step is the first step to make sure that the variable is isolated. After that, you can decide direct and joint would be if there's no fraction at all, or inverse or combined if there's a fraction, and look at where the variables are. So in this first case, number 1, I see a division sign, which means it's automatically going to be either inverse or combined. And since there's only a variable in the denominator, there's nothing in the numerator, I know right away that this is an inverse. Number 2, I can really look at it in one of 2 ways. Okay? I know that a lot of us immediately see this fraction bar and think, oh, it's got to be an inverse because we see division, because really this is the same as saying y equals 1x over 2, which would simply be x over 2 since we don't need to write the 1. However, if it's going to be inverse, the variable needs to be in the denominator. In this case, the variable is not in the denominator, so you really should look at it as I'm taking half times x. Since it's multiplication of a constant and just one variable, that means that this is direct variation. The next one has a division bar and a variable in the denominator, which automatically tells me that it's inverse. But there's also a variable in the numerator, so that makes this one combined because we're varying directly with x, but inversely with w. So this would be a combined variation. Okay, the next one, it's all the same line, right? So it's multiplication, which means either direct or joint. And in this case, since my constant, which is 3, is being multiplied by 3 different variables, I automatically know that it is joint because there are multiple multiplications. Looking at number 5, again, I know a lot of us will want to say inverse because there's division, but there really isn't division. It's saying I'm taking a third and multiplying it by x and by z, which makes this direct. Now number 6 is one of those stumper ones because there's no multiplication between it, there's no division, right? So that means it's not direct or joint because there's no multiplication. It's not inverse or combined because there's no division, which means it's that elusive none because there's no multiplication and there's no division. All right, now let's take a minute and look at number 7, which to me is one of those special cases because it applies number 1. We need to make sure that one of the variables is isolated. In this case, no variable is isolated because x and y are together. So I tend to go with getting y by itself as opposed to x, but to be honest, it wouldn't matter which one you dealt with. So the idea here is that I'm going to have to get rid of my x by dividing by x on both sides. Now, remember when you're doing that, right, that if I divide by 1/4 by x, I could look at that as dividing by a fraction, and really, if I'm doing 1/4 divide it by x over 1, that's the same thing as saying multiply by the reciprocal, so it's 1/4 times 1 over x, which leads me to y equals, well, 1 times 1 is 1, 4 times x is 4x. I see a division sign. I have my variable in the denominator, which means that this is an inverse. And the last one, there's a division sign with a variable in the denominator, so I know it's inverse, but there's also a 3 times z, which makes it direct. So since I'm combining the direct and inverse, this is a combined problem. All right, so now we're going to go ahead and we're going to take a moment to actually create them and apply and find the constant on our own. So the big part of this next one is finding the variation constant on our own. In the problems up here, my variation constants were things like 3, 1/2, 78. So those numbers there are the constant variation, and that's what we need to find. So over here on the side, I'm going to kind of make my own little step list. So when the constant is not given, find it. Okay, so if they don't give you the constant, you're going to have to find it first. And we're going to write some steps over here about how we were to find this. So step 1, I would have to read the problem first. I'm not going to write that down because hopefully we all realize that. So it says a varies directly, so I know it's going to be multiplication. So a varies directly as x. So when I look at this very first part, that first part is giving me my general formula. So that's going to be my step 1. Write the general formula. So a varies directly means I'm going to multiply the constant by x. Now that I've got that piece, as I read on, it says that a equals 6 and x equals 2. So since I know what my a and my x are, I can go ahead and substitute those given values in. So step 2 is going to be substitute given values. So in place of a, I put 6. In place of x, I put 2. And we're multiplying between these. Well now, since I didn't have the constant, I can find the constant by just solving for k. So that's going to be step 3. Solve for the constant. Solve for constant k. In this case, that would mean dividing by 2, which tells me that my constant is 3. Now, I'm not done with this problem, right? Because at first it just says find the constant of variation. Awesome, I just found it. We can check that off our list. But as I read on, it says, and write a function that expresses the relationship described in each statement. So that takes me to what my step 4 is going to be. And step 4 would be to write final formula with the number in for the constant k. So in this case, our original formula was a equals kx, but now I know my k is 3, so I can say a equals 3x, and this is my function that represents the relationship between a and x. At this point, if I were you, I'd pause the video and try to do number 22 and 23 on my own, and then when you finish, check and see if you've got it right. All right, so number 22 says W is inversely proportional. As soon as I see inversely, I know I'm dividing. So W equals K. It's inversely proportional to Y, so Y goes on the bottom. Next, I see that they show me that my W is 10 and my Y is 2. So I know that that really means that 10 equals K over 2, and now that's the equation I need to solve. Well, in order to get K by itself, we would simply multiply by 2 on both sides, so 20 would equal K. And then we have to write our final formula. So W equals, but now instead of K, I know my K is 20 over Y. Okay, so let's take a minute and look at number 23. So in number 23, when I first start looking at it, it says that V varies directly as A. So as soon as I see directly, I should know that it's multiplication. So we can say V equals the constant K times A. Then as I read on, it says and inversely, which means immediately I know I'm going to be working with division. So I'm going to divide by the square root of y. So make sure you're really careful that you actually put the square root in there with it. So now we've got v equals ka divided by the square root of y, and then I can go ahead and plug in the information that they're giving me. So v is 12, a is 2, y is 9. So I'm going to put a 12 in the place of v, k I don't know, times a, which is 2, over the square root of 9. And make sure you're really careful to be sure to put the square root in there. It's very easy to forget to do that. And now, to me, the easiest thing would be to actually reduce that square root so I can get rid of it. So the square root of 9 is 3, so my new equation is 12 equals k times 2 over 3. And now that I've simplified that square root, I can go ahead and work to get the k by itself. So first I'm going to get rid of dividing by 3 by multiplying each side by 3. So we would end up with 36 equals, the 3's cancel, so k times 2. And then I'm going to divide by 2 to get k alone. So I would end up with 18 equals k. Now that I know what my constant is, I can go ahead and write my equation, which would be v equals, instead of k, it's 18a divided by the square root of y. All right, now we have the last piece here, which is to find the requested values. Okay, a lot of this is the same as what we were doing before. So when I go to make my steps for this, step 1, okay, when they're requesting that you find the value, step 1 is going to be what we just did. You need to find the constant of variation first. You still need to find that constant of variation as your first step. So all those steps that we just took are going to be the first steps that we take to find a requested value. So if y varies directly as x, so again, directly means multiplication, so y equals k times x. They tell you that y is 12 and that x is 9, so I'm going to put 12 in for y and 9 in for x. Then I'm going to solve for k, so when I divide each side by 9, we end up with k equals, well, 12 over 9, but 12 over 9 reduces to 4/3. So now I have my new equation, which is y equals 4/3 x. Now in our previous one, this is where we would stop. But now that we found our constant of variation, we actually need to go a step further because it's asking us to go further and to find the value of y when x is 21. So now that we've found our constant of variation, just like we did before, and we wrote our formula, so step 2 was write formula with constant substituted in. Now we can actually use that formula to find the missing value. So we're going to use step 3, use formula to find missing value by substituting and solving. So I'm going to take 21 and put it in place of the x, and I don't know y. So y equals 4/3 of 21, and 4/3 of 21 is 28. So I found the missing value, and I found the general formula with the constant of variation plugged in. So you can pause the video if you would like, and then check to see if you did 25 correctly. So it says S is inversely proportional to T. So that means we're going to divide. So S equals K divided by T. They tell me S is 15 and T is 7. So 15 equals K over 7. To get K by itself, we'd multiply both sides by 7, and we'd get 105 equals K. Since now I know my K, I can go ahead and write my general formula with K plugged in. Which is S equals 105 over T. And then we are going to work to find out what S is when T is 3. So I still don't know my S. 105 is my constant, dividing by T, which in this case is 3. So S equals 35. So sometimes you can stop once you find your general formula with the constant plugged in, and sometimes you'll have to go a step further. So when you see that find S or find something when another variable equals something else, you should probably stop, ignore that piece, work to find your general formula first, and then you can plug everything back in. And that concludes the Unit 9.5 notes.